Hello everybody, welcome to 2.7 where we'll be solving problems with rational numbers. Here's your journal page set up, a special attention to the standard which says that we need to be able to solve real world and mathematical problems involving the 4 operations with rational numbers. So our learning targets today are I can represent situations with expressions that include rational numbers, and I can solve problems using the 4 operations with rational numbers. So one of the key details today, and when we're working through some of these more complex word problems, is knowing which operation, addition, subtraction, multiplication, or division, is necessary to solve our problem. So a reminder of the 3 reads that I often use to help me make sense of word problems. Make sure that you're asking yourself what the situation is about, what words you don't understand, what information is countable or measurable, aka what are your numbers, and how might you begin to solve these questions. And as you answer questions, don't forget to include your units and make sense of those problems in the context of the story. So let's start an example. Draining and filling a tank. So water tanks, this is one that is up in my neighborhood, up in North Portland, kind of near St. John's. Water tanks just store all of our drinking water so that they can then be dispersed through the neighborhoods. That's what these stories are about. So we have a water tank that is being drained. Due to a problem, the sensor does not start working until sometime into the draining process. I'm going to highlight that because that's an important piece of this. The sensor does not start working until sometime into the draining process. The sensor starts its recording at time 0 when there are 770 liters in the tank. Again, I highlighted that because that is telling me some of my countable numbers. When time is 0, we have 770 liters in the tank. All right, some more information. Given that the drain empties the tank at a constant rate of 14 liters per minute, complete the table. I have some more information to highlight there. I know that this drain is emptying at a constant rate of 14 liters per minute. Okay, so one thing right off the bat that is different about this story than some of the other stories we've worked at is when our time is 0, right here, you can see time is 0. Our position is not 0. Our position of the water is actually 770. So we've seen expressions before where, I believe that was in lesson 3, maybe that was lesson 1. But where we were having our starting position of 0, and then we were adding or subtracting based on if we were going right or left, our speed and direction. In this case, because we're not starting at 0, we need to make sure our starting position is always 770, because that is how much water is in the tank. Okay, since we are draining at a constant rate of 14 liters per minute, that means that our change is going to always be negative 14. So we're going to take that 170, which is our starting point. We're going to add the product, aka the multiplication of our time. So in this case, there's 5 times negative 14, because that's the rate at which things are changing. So I could write this as our expression is going to be 770 plus times our rate is going to give us how much water is in this tank. So plus 10 times negative 14. Go ahead and pause this and see what calculations you come up with. All right, here's what I got. And I anticipate the most common error that if your numbers are not like my numbers that you made is probably order of operations. We can see here in this first example 0 times negative 14, that's our multiplication, so that has to happen first. So we could look at this expression kind of like 770 plus 0, because that 0 times negative 14 is just 0, which is also the change in water. And then we could look at 1 times negative 14, and that means that this expression is actually 770 plus negative 14. So we can see that multiplication happened here. There's our change in water. 5 times negative 14 is negative 70. So that's 770 plus negative 70. There's that change in water. And then 10 times negative 14 is negative 140. So there's that change in water. This problem will show up again in your homework, or in your practice problem. Sorry, don't know why I said homework. All right, let's check out a different scenario. So in 2013, Hosford installed some solar panels on its roof as a step towards becoming a green building. Pacific Power, one of Portland's electric providers, charged approximately 18 cents per kilowatt hour. Now, a kilowatt hour is a way that we measure how much energy we are using. So every kilowatt hour an electric customer uses, they get charged 18 cents. Okay, they are also offering a credit of 3 cents for every kilowatt hour of electricity a customer with solar panel generates but doesn't use themselves. So a credit, in this example, a credit means that it is money earned through generating solar power, and this money is then subtracted from the total amount owed at the end of the month. So if you have a credit, that is money you don't have to pay. Yay! Okay. Let's check out the problem. All right, so first thing I wrote down is always looking for what it is that we know. So we know that we are being charged 18 cents per kilowatt hour and that we're getting a credit of 3 cents per solar kilowatt hour we've generated. And this first question is just asking us, though, this month, Hosford's charge was $205.90, and they received a credit of negative 20.09 on this month's bill. What is the amount due this month? So in this case, the only operation we really need is some addition. We're just going to say, well, the amount they charged plus the credit is our total bill. So the charge plus credit is total bill. So $205.90 plus negative $20.09 means our total bill was $185.81. So now with this same scenario, we have the same charge and the same credit. We're being asked to find out how many kilowatt hours Hosford used, and also how many kilowatt hours Hosford generated but did not use themselves. So I'm going to just color code these. We know that the kilowatt hours used is going to be related to the 18 cents per kilowatt hour, and we know that the solar credit is going to be related to the amount they give us per hour. And in the actual problem, we know that the kilowatt hour is going to be that initial charge, and the solar credit is going to be represented by the amount of credit we got. I want you to pause this and see how you would set this up, and then come on back and I'll do it. All right, here's my setup. I'm coming up with this formula where we have our hourly rate multiplied by how much time we are using will equal our total bill. And so for the sake of our kilowatt hours, we would say, well, that's 18 cents times however many kilowatt hours we use is, in this case, going to equal 205.90. And for our solar credit, if that is 3 cents off our bill times however much we use, gets us that total credit of $20.90. So I know those are negative numbers right there, but remember, those are credits. So that is money being removed from our bill. So I'm going to start with just the kilowatt hours. In order to solve for this unknown time, since that's being multiplied, I'm going to set up the equation where I'm going to take that 18 cents and go ahead and turn it into a divisor. So I'm going to say, well, that means X, which is time in this case, is going to be 205.9 divided by that rate, divided by 18 cents. And I'll do the same thing for my solar. Say, well, that means my X, or that time, is going to be the total credit, so 20.09, divided by the credit per hour, negative 0.03. All right, and so when I do those calculations, that means that or Hosford, not me, Hosford used a total of 1,143.89 kilowatt hours and generated 669.67 solar hours. So in this activity, when we were talking about the water tank, our positive numbers are going to represent water that is being added. A negative number would have represented water being drained. In the activity about the price of electricity, positive numbers would represent money the customer owes the company, and the negative numbers are representing money the company owes the customers. And these scenarios will show up in your practice problems. So here's a quick you try it. Go ahead and give it a try. We have a bank that is charging a service fee of $2.50 per month for a checking account. The bank account has $26.50 in it. If no charge is deposited or withdrawn, except the service charge, how many months until the account balance is negative? Go ahead and fill out the what you know, what you're being asked to find, and then calculate that answer. All right, so here's what I came up with. We've got the $250 per month. We've got $26.50 in the account. We're being asked how many months before there's a debt. I said, well, that's $2.50 times however many months we can do before we are out of money. So 26.5 divided by 2.5 is going to equal 10.6, which means that my M, or that unknown that stands for months, I have 10.6 months before I am in debt. All right, go ahead and do those journal problems. Good luck, y'all.